Hello everybody, welcome to Statistics and Theory. This is Dr. Vahid Aryadust. In this video I'm going to demonstrate how to run a regression analysis with both categorical and continuous variables. I'll also show you how to interact the continuous and the categorical variables and create an interaction variable. If you have not watched my previous videos about multi-categorical multiple linear regression, please watch these videos on my channel. I will leave the link for you. And in addition, I'd also suggest that you watch those videos on linear mixed effect models because of the similarities of what I'm going to present today and those linear mixed effect models. Alright, so let's get started. In this demonstration, I will show you how to predict this y variable, which is comprehension, using some of the variables that are to the left side. I specifically have two continuous variables, grammar and vocabulary, and have two categorical variables, gender and stream. And these two are categorical, and they can also be interacted with these continuous variables in our regression analysis. The first thing that I suggest that you do is to go to the exploration menu in Jamovi, in the Jamovi interface, and click on scatter plot. Under scatter plot, move comprehension to y-axis, and one of your continuous variables, in this case vocabulary in my analysis, to the x-axis slot. This will be generated for you. Now, what we want to do is to figure out whether the relationship between comprehension and vocabulary, which is the independent variable, is related to gender or is different across the two genders in this analysis or not. I'm going to move gender to group, and you see it has been color-coded for us. Under the regression line, I'm going to select linear, so you will get two different regression lines, and you can also get, for example, the standard error around it to just make it more interesting. As you see, the relationship between vocabulary and comprehension, vocabulary on the horizontal axis and comprehension on the vertical axis, is mediated through female and male, or that's the gender variable, meaning that, as you can see, there are two regression lines, and they're not exactly the same because they interact with each other. So this indicates that the relationship between vocabulary and comprehension is somehow affected by another third variable, which is gender. In the same way, you can move out the first categorical variable and test with other categorical variables that you have in your data set, in this case stream. Okay, stream has got three categories in the context of Singapore's educational system. These include normal technical, normal academic, and express. And as you can see, there are three separate regression lines, one per each of these streams. So this indicates that these relationships are basically based upon or are dependent upon what stream you are looking at. Now I'm going to go back to the regression menu here and start regression analysis. What I will do in this analysis is I'll quickly run a linear regression analysis like what I did in previous videos, but I also show you that basically choosing linear models where you want to interact a categorical and a continuous variable would be a much better choice, and that's what I highly recommend. So I will present the results of both and compare them. Let's go to regression, linear regression analysis. Under linear regression, our dependent variable is the continuous comprehension variable. So I'm going to move it here. We have two boxes here for our independent variables. One of them is factors, which is the categorical box, and the other one is covariates, which represents the continuous variables. So I'm going to move vocabulary to covariates because it's continuous, and I will move gender. I'll start with a simple analysis first, to factors. So the analysis has been started, but we will get, as you see, I've gotten an error message which I'm going to solve. If you have watched my previous videos, I got the same error message. Basically, you have to go to reference level and choose one of the two reference levels, either male or female, or in your data any other reference levels that you have. -999 stands for missing values, so it can't play a reference level. So I'm going to click males because it has been represented by 0, and it's better to choose a reference level which has got the lowest amount, in this case 0. Even though it's a nominal variable, it's still easier to make sense of. Now our regression analysis has been performed. You can go through the model fit and see what kind of model fits you would like to get. I suggest that you get the R squared rather than R squared and adjusted R squared, and the F test. And for model coefficients, it's recommended to choose ANOVA tests and perhaps standardized estimates if you like to. And under save, if you like, you can predict. You can save the predicted values because you can use them to plot the results. All right. So in this regression analysis, we have several variables. In fact, 3 variables. One of them is the dependent variable compre, which are being predicted by vocabulary and gender. Overall, I've gotten an R squared value of 0.1920, which is around 20%, which means that the model can predict around 20% of variance in the data. Not too high, but I wouldn't say it's too low either. After you adjust for the complexity of the model, the adjusted R squared is only very minimally smaller than the R squared value, which is pretty fine. Overall, our model returns a significant p-value, which indicates that the amount of variance is being significantly predicted by our predictor variables. The omnibus test also, as I have discussed in previous videos, shows that the vocabulary influence on comprehension is statistically significant, as indicated by its p-value right here, but gender doesn't seem to have a significant contribution to the variance that is observed in the comprehension scores. And finally, the model coefficients in the regression analysis include intercept and vocabulary and gender itself, in which we've got males versus females. Now, for the intercept, which I have discussed in detail in previous videos, we have a significant p-value, which indicates that the intercept of this model is statistically different from 0. So it's not 0. So it's very obvious that it's 2.0447. And after doing a statistical test, we find out that the differences between this and 0 is statistically significant. Another observation is vocabulary is also a statistically significant predictor of comprehension, as indicated by the p-value, and its estimate is 0.31. Its standardized estimate is 0.4418, which indicates that if vocabulary increases by 1 standard deviation, comprehension increases by 0.4418 standard deviations. This is the difference between standard estimates and estimates themselves. The units are different, in other words, in these two categories. And finally, the differences between males and females is this much, minus 0.016, which is not statistically significant at all, as indicated by its p-value. Now, the question is, how can we create an interaction between gender and vocabulary so we can separate the regression lines in this way. In other words, the relationship between vocabulary and comprehension will be dependent upon what kind of gender we're looking at. Unfortunately, this menu, the regression menu, does not do that for us, but the good news is there's another menu here which is called linear models, specifically GAM-LJ, which allows us to run this analysis. If you have not gotten this by default on your Jamovi interface, you got to go to modules and click on Jamovi library and find GAM-LJ and just install it, and come back here. You will see that it immediately appears on top on the toolbar on top of your Jamovi interface, and you can run the analysis. So let's click on linear models and go to general linear model. In this case, in this menu, we can move vocabulary to dependent variable, comprehension to the dependent variable box there, and we want to predict comprehension with vocabulary, as I did before, and with covariate here, and with gender. So it's exactly the same sort of analysis that I just demonstrated, but now within the general linear model menu. The R codes for this analysis has been written here. As you can see, compre is predicted by 1 plus vocabulary and gender. So these are the two predictors. This 1 stands for our intercept. So the model has gotten an intercept as well. The R-squared value and the adjusted R-squared value are exactly the same as what we saw before. And if you go through these outputs, you will find out that the p-values and also the estimates and standardized estimates are almost the same. Actually, exactly the same here. In this table right at the bottom, you see the estimate of the intercept is the same as the estimate of the previous intercept, if I'm not wrong. The estimate of the intercept here is different because here we're looking at a different sort of intercept. I'll explain that in a second when I get there. Anyway, but the vocabulary and the gender continue to have the same estimates, and well, the differences are respectively significant and not significant for the two variables. Now we need to create an interaction variable between the categorical and the continuous variables. How do you do that? Under the model menu, you have to choose gender and vocabulary. Just press down Shift on the keyboard and highlight both of them. Under this arrow menu, click interaction. So you'll add an interaction variable. In this case, you have basically separated the slopes of the two gender groups, in this case for vocabulary, meaning that vocabulary you assume has got a different slope for males and a different slope for females. And then you can compare these two slopes to figure out whether they are statistically significant from each other or not. Let's go back to our regression output and look at the model first. Under model information, you'll see that a new term has been added to our regression code, which is gender by vocabulary interaction. That's what we exactly did. Interestingly, though, the R-squared and adjusted R-squared values do not change much. So it means that if you add this new interaction vocabulary to your model, it does not contribute to the improvement or optimization of the predictive power of your regression model. So that's something that we need to take into account. Under the omnibus test, though, we see that the gender effect has not changed that much. Nevertheless, the p-value has gone down a little bit, but it doesn't reach statistical significance. So it's not statistically significant yet in this model. The vocabulary times gender interaction in the same way is not statistically significant, as indicated by its p-value. And this indicates that this interaction term does not contribute to the optimization of your model at all. Now, if you scroll further down and under the mixed effect parameter estimates, you can see that vocabulary times gender 1 means that vocabulary times gender times female has been compared with vocabulary times male. In other words, as I mentioned, the slopes of vocabulary times female and vocabulary times male have been compared with each other, which in this case again is not statistically significant, as you can see in the p-value section. So let's move back and remove gender and replace it with stream, because stream has got 3 categories and it might be even more interesting to include stream. First of all, I want to run this analysis without including any interaction component in the model. So the model is represented in this way. Comprehension is predicted by the intercept, which is 1, plus vocabulary plus stream. So we have got 2 predictors. As you can see, the R-squared value and the adjusted R-squared value have increased from around 20% in the previous model to 27 something percent, and after adjusting for the complexity of the model, it remains around the same. In the Omnibus ANOVA Omnibus test window or box, you can see that stream has a significant impact on the comprehension scores as indicated by its p-values. And in the same way, vocabulary has also gotten a significant impact on comprehension. Therefore, both of these contribute significantly to the variance that is observed in comprehension. Now, in this case, we also have a partial eta squared value, which I have discussed in multiple previous videos, which represents the effect size. The effect size of stream is much higher than the effect size of vocabulary. In fact, it's getting closer to what we can call, a strong effect size, because anything above 0.14 is considered strong effect size, and it's getting closer to that. But vocabulary has got the effect size of 0.07, which indicates that it can explain 7% of the variance in the data, and it's around something between medium and low effect size. It's not a very high effect size, I would say, but still, it's statistically significant, and its impact is not due to chance. The interesting part of this output is when we are looking at the interaction effect. So let me create an interaction effect first. So stream by vocabulary interaction is created, and we should immediately check the model first. The comprehension is predicted by the intercept plus vocabulary plus stream plus their interaction. And the R-squared value hasn't changed that much really, but we can see some kind of change. The question is, as always, whether the interaction term between vocabulary and stream is statistically significant, which is not in this case, because the p-value is, as you see, much larger than 0.05, which is larger than in other words, larger than our alpha level. So as a result, its partial eta squared value is small and doesn't make sense at all, because its p-value is not statistically significant. Finally, we'll look at the fixed effects parameter estimate window, and in this table we can see that vocabulary stream, which has been operationalized as vocabulary normal academic stream versus vocabulary normal technical stream, have been compared with each other. So we're comparing 2 of those regression slopes that I presented before, and interestingly, there is no statistical difference between them, so I'm not surprised to see this, because previous analysis also under the ANOVA omnibus test showed that they're not significant. In addition, the differences between the vocabulary for the express group and the vocabulary for normal technical is not statistically significant either, as indicated by its p-value. Every p-value has got a t-value associated with it, which is in this column. And as you can see, the t-value is also pretty small in both cases and doesn't reach 1.96 to reach statistical significance. And so it's not surprising that the p-value indicates that the relationship between those variables and our dependent variable is not significant. In addition, as I have discussed this in the previous video, stream 1 is being compared with the second stream, which is indicated in this way. Normal academic and normal technical are being compared with each other, and this is the result, which is statistically significant, as you can see in the p-value. And the express and normal technical are also being compared with each other, which is statistically significant as well. In this case, our normal technical group is known as the referent group, and these two other groups are being compared against this. Finally, let's look at the predicted values. And if you click on options predicted, you'll get it. Since I have run the analysis twice, I have generated two predicted models. For the first one, I have some missing values here. For the second one, I don't have any missing values. And this is because I have incorporated an interaction term, so it has estimated the predicted for all. So we can basically look at the relationship between the predicted values and the dependent variable, again in the same way that I showed through the scatter plot menu. So in this scenario, I want to move comprehension to the predicted value of comprehension to the y-axis, and the predictor, in this case vocabulary, to the x-axis side, and this is what we can get. Now, I also would like to add stream as a grouping variable, so we will get three separate regression lines. This is an indicator that when you incorporate stream into the analysis, the relationships between vocabulary and comprehension predicted scores will be different. But interestingly, as you saw, it doesn't reach statistical significance. So even though we see that there are significant differences or significant distances between the two, these areas, these discrepancies between the location of these three regression lines doesn't mean much, because the slopes, as you can see, are more or less the same. They are almost on the same horizontal line, which are parallel somehow, even though the differences between the first one, which is express, and the second one in the middle, which is normal academic, is not exactly like two parallel lines, but they don't seem to reach any significant difference. Therefore, the interaction between these three categories is not, and the predictor, the continuous predictor, is not statistically significant. One last thing that I'd like to show you here, everyone, is that you can basically choose to do post-hoc analysis, or you can choose to change your factors coding from simple all the way to polynomial. I have discussed these extensively under this playlist, where I have discussed linear mixed effect models. Please watch those videos if you want to get more information about this menu here, as well as covariate scaling, which is centered, z-scores, log, and non. Again, I have discussed this in details, in the videos about linear mixed effect models. So this brings me to the end of this video. I hope you found this useful, and it will help you in doing an interaction analysis between categorical and continuous variables in your data. Thank you very much for your attention. If you like the video, please give it a like and subscribe to the channel, and have a great day. Thank you.